Hello and welcome to Scanner Today's Let's Talk AI podcast, where you can hear from AI researchers about what's actually going on with AI and what is just clickbait headlines. This is our latest Last Week in AI episode, in which you can get a quick digest of last week's AI news, as well as a bit of discussion between two AI researchers as to what we think about these news. To start things off, we'll hand it off to Daniel Bashir to summarize what happened in AI last week. We'll be back in just a few minutes to give you that discussion about these stories between AI researchers.
Hello, this is Daniel Bashir here with our weekly news summary. This week we'll look at AI's resource divide, AI for summarizing AI, and how Facebook is or isn't dealing with hate speech. One of the most pressing topics of the age of deep learning is the amount of compute and money required to train and use modern AI systems. As VentureBeat reports, AI researchers from Virginia Tech and Western University found that an unequal distribution of compute power in academia, along with a pattern of academics leaving prestigious universities for industry, is furthering inequality. Given the need for massive compute, the bleeding edge of AI has recently been shaped by a few elite actors. A December 2019 analysis labeled Google, Stanford, MIT, CMU, UC Berkeley, and Microsoft as the top 6 contributors at leading AI research conferences. The researchers also found that universities ranked 301 to 500 by the US News & World Report have published on average 6 fewer papers at AI research conferences since the rise of deep learning. While there are plenty of problems here, solutions are needed to democratize AI research. The co-authors say their findings present evidence of the need for a national AI research cloud, which was backed by major universities, tech companies, and US senators in June. Hopefully this and other ideas for mitigating the gap will come to fruition. If you're an AI researcher doing a literature review, this next story might be right up your alley. On November 16th, the Allen Institute for Artificial Intelligence rolled out a new AI model for summarizing scientific literature. As the MIT Technology Review reports, users of the AI-powered scientific paper search engine Semantic Scholar can now see one-sentence TLDR summaries under every computer science paper. Summarizing text has been a popular natural language processing problem. The Allen Institute's model involves generating new sentences and uses the same architecture that powered OpenAI's GPT-3. Our last two stories concerned Facebook and speech moderation. Facebook has continued to claim it's becoming better at detecting and removing objectionable content from its platform, despite the fact that misleading and harmful posts end up in millions of users' feeds. As VentureBeat reports, Facebook's investment may be for naught. BuzzFeed News reported this week that according to internal documents, labels being attached to misleading and false posts around the 2020 US presidential election had little to no impact on how the posts were shared. Facebook has pointed to incremental performance gains in proactively detecting hate speech, but there's plenty of reason to question its effectiveness, given the variance and evolution of hate speech, the use of code names, and other confounders. Beyond hate speech detection, Facebook has drawn plenty of ire for its failure to enforce hate speech policies. In addition to civil rights groups' criticism, lawmakers remain unconvinced that Facebook is catching enough harmful content. As The Verge reports, 15 US senators pressed Facebook to address posts attacking Muslims worldwide last week. When the senators requested more country-specific information about Facebook's moderation practices and the targets of hate speech, CEO Mark Zuckerberg defended Facebook's moderation practices and indicated that Facebook might include that data in future reports. That's all for this week's news roundup. Stay tuned for a more in-depth discussion of recent events with Andre and Sharon.
Thanks, Daniel, and welcome back, listeners. Now that you've had the summary of last week's news, feel free to stick around for a more laid-back discussion about these news stories and maybe some other news stories by two AI researchers. I am Andrei Krenkov, a third-year PhD student at the Stanford Vision and Learning Lab. I focus mostly on learning algorithms for robotic manipulation and reinforcement learning in my research. And with me is my co-host.
Hey guys, I'm Jackie, also a third year PhD student, but at the Carnegie Mellon University's Robotics Institute. I do research also in robot learning, in particular, how we can use simulations to make robots more adaptable in the real world.
Indeed, yeah, we have Jackie here as a co-host now. Sharon, who is usually our co-host, is out in Hawaii, I believe, relaxing and inaccessible.
Wow.
So yeah, we're gonna just try it out a bit differently. Jackie and I have known each other for a couple of years now. We started a whole Skynet Today thingy, and this podcast grew out of that. And also we started a newsletter, so we've been keeping pretty close track of news for a while.
Yeah, it's amazing to see how Skynet Today has really grown over the last couple of years, and I'm very excited to be here.
Yeah, it's kind of been something we have been doing as a side project during our PhDs almost.
Yeah.
Well, let's get going with this discussion. So our first article here is "The way we train AI is fundamentally flawed." And this is from the Technology Review. And somewhat unusually, this first news story is actually directly based on a new paper. So this is a paper from Google that had 40 researchers across 7 different teams. So it was kind of a big paper that basically pointed out that, as the title says, there's a serious problem in how we train AI models. And they call this problem under specification. Basically, what they meant is that for a given training set of data, you can get many different solutions. And so as a result, your model could perform very differently out there in the real world, depending on totally random factors. Literally. So if you set a random factor of a random seed of how you initialize your weights, when you use your model on data that is a little bit different or related but slightly different from the test from a train set, it may or may not work. Okay, so this it's not news that generalization to new data is hard. What is news is that depending on completely random stuff, even in supervised learning where we thought things were pretty robust, that's not the case. And so this paper posits that we need to know this, and we need to do a lot more testing to know how things perform in the real world, and not think that if we have a train test split, everything's fine. I wonder, Jackie, did you see this paper go around at all? And what's your take on these results?
Yeah, I think one thing that I kind of found surprising was one of their conclusions was on how you weren't able to tell how well a model would perform on test data by looking at their training performance alone. So you would have all these different models initialized with different random weights, as you mentioned, and they would all achieve similar training performance at the end. So maybe they all get 90% or something. But based on that, you can't really pick out how they would perform on novel data, and turns out there's actually a huge variance when you apply these different models, even though they have the same training performance. So I thought that was very surprising, and also makes the problem a lot harder. And I think a lot of this has to do with, I guess, part of this growing pains of really industrializing new advances in AI and in deep learning. When we actually put them on real systems that have real consequences, you need to be a lot more thorough, right, about testing their capabilities, catching bugs, catching issues. And I think this is a step towards that, making models more robust and all. But yeah, it's a difficult challenge.
Yeah, I think it's kind of an interesting glimpse inside of Google, perhaps, of when they try and take these research results and actually make them into products that have to deal with real world data, not just a test set that is from the same distribution as your train set. I suppose this is what they find, is that it's kind of random, and you can have a very hard time predicting if your thing is actually going to work or going to fail in some silly way. So same as you, I found it pretty striking. And I think both of us are used to this in reinforcement learning. Randomness
Yes.
can make your thing work or fail, but for ImageNet, for image classification, this is kind of weird.
Yeah, I guess on top of that, I mean, at least right now, people have the impression that supervised learning is quote and unquote solved. I mean, it's not solved, but it's being used in real systems. There are best practices that people have documented. I wouldn't say there is a very um, uh, there isn't a very hard and fast rules when it comes to just making your model more generalizable. There's a lot of domain expertise that comes in with particular tasks that you need to do to clean your data, to train it on various different losses, hack around the model a little bit, and so this is all sort of kind of magic-y things.
It's like a black art still, right? There was a discussion at Stanford a while back that I really liked where one of the professors, I think it was Michael Jordan, made a very cool point, which is AI and machine learning, in a sense, is sort of like electrical engineering was in its infancy when people were just playing around with electricity and sort of figuring things out, and none of it was systematized and none of it was very formal. But we could see AI and machine learning becoming a real engineering discipline where we understand data and we understand generalization and we understand a lot of this stuff, and with more formal techniques and more formal procedures. But we are nowhere near yet that place, and this paper is a testament to that.
Exactly. But that does make this a very exciting area to do research in, and maybe one day we'll get reinforcement learning up there as well.
One day. But speaking of trying to apply models in the real world and how it may or may not work, we have next a pair of articles, one from VentureBeat titled "Facebook's Improved AI Isn't Preventing Harmful Content from Spreading," and also an article from The Verge titled "Facebook Says AI Has Fueled a Hate Speech Crackdown." So interestingly, kind of disparate stories. And yeah, the short version is Facebook says that it now proactively detects 94.7 of hate speech it removes, which moved up from 80% in 2019. And they say they do that using a cutting edge AI model called the Linformer. And the Linformer, in fact, was actually published pretty recently. So it's another case of trying to put something from research into production. But yeah, they say it's good, but criticism here from VentureBeat saying that harmful content is still spreading, and maybe they're not doing quite enough. I don't know how big are you on Facebook, Jackie? Do you think they're doing all they can? Do you think they could do more?
I mean, I definitely think they could do more, but I do recognize this is just a hard problem in general when it comes to content policing or recognizing content that violates whatever standards that Facebook has. I mean, I do think that they're working on this in good faith, right? That they are putting a lot of effort into it. Obviously not perfect. A couple other efforts. I think this article details. I think one I found was pretty interesting was this deepfake detection model trained over 100,000 videos from this earlier public data set, the deepfake detection challenge. So yeah, they are pushing on new novel methods, and we'll see. I think the thing about this 94% number, though, it is that this is not like a third party audit by a third party, right? This is Facebook's own internal transparency report. So you may or may not need to take that with a grain of salt. Yeah.
Yeah, exactly. That's a good point, I think. And some of these criticisms with respect to Facebook have been about sort of the decisions they make that are more editorial. So, for instance, sometimes having political favoritism or reluctance to act on research that might be sort of borderline. So it's noted here last week 15 US senators pressed Facebook to address posts attacking Muslims worldwide, requesting more country specific information about its moderation practices and targets of hate speech. So there is, of course, a gray area of what is hate speech across cultures. And there, I think it's always going to be a bit tricky. And certainly Facebook is doing well on the obviously terrible things, hopefully, but I think it does come down a little bit to the users of Facebook to pressure it to, not take the easy road in some cases and to actually act on things where, as a user of Facebook, you're uncomfortable. And if you think they're allowing such content, you would leave.
Yes, although I think for most people that is easier said than done. The correct direction for Facebook and for many other social media platforms is obviously be more proactive in these content violation detections instead of relying on users, and also rely less on moderators. We have seen articles that detail sort of the mental health, the toll that comes from just reviewing day in after day out of these horrific posts, honestly, and that's a tough job to do, and that definitely they need to work more on algorithmic solutions.
Yeah, for sure. And another thing I found interesting here, you actually mentioned the need for an external audit. And these articles note that a New York study published in July estimated that Facebook's AI system make about 300,000 content moderation mistakes per day, and that a lot of those posts slip through the filters. And so you unfortunately still need humans in the loop to do a lot of this content moderation, which, as you say, is pretty mentally challenging to keep seeing hateful stuff day after day. So certainly Facebook should be commended for its efforts, just as much as it should be kind of investigated and should be inspected by external auditors. I think I agree with you there. And on to our next story from Wired. And we have, I guess, kind of a set of bummer articles today. Not much positive going on, but it happens with AI. One of the classics that we've covered as far as themes on this podcast quite a bit. This one is on AI bias, and it's titled "When AI Sees a Man, It Thinks Official, a Woman Smile" from Wired. And it's about how Google's cloud image recognition service, when applied to members of Congress, would label men with labels like official and business person, and for women with things like smile and chin. So things that have to do with physical appearance rather than, let's say, stature. And this article notes it results in women receiving a lower status stereotype that women are there to look pretty and men are business leaders. And this is, following up on previous results that actual commercial systems, and this being an actual commercial system, have biases like this when it comes to speech recognition, when it comes to race, lots of things. Yeah, Jackie, were you aware that actual commercial systems have these kinds of flaws already?
Yeah, I think we've seen a lot of reports and a lot of interest in this area, especially in the last couple of years, on how rampant these bias issues are with commercially and publicly available AI services. I think, there's a lot of dimensions to stories like this. One might be incentives or the resource allocation, right? Because this isn't the fact that trained deep learning systems for facial recognition or for whatever system there is, the fact that they have bias, like this isn't necessarily news. We've known this for a while. And given that, why do we still see right bias in these models? And yeah, I don't know. Maybe part of it is that companies need to be more proactive in actually allocating resources to audit, to check for themselves whether or not their models have bias, and then actively fix those things. These things, they cost money, they cost time. Maybe they're not incentivized to go down that route. It is a little discouraging to see a lot of the reports here are coming from academia. There's all third parties like poking at these companies and saying, "Hey, maybe you should fix this," instead of the companies fixing it themselves.
Yeah, exactly. And it's interesting. I was listening just earlier today to an interview of Margaret Mitchell, who's one of the leads of the ethical AI team within Google. And that team has published a lot on how to avoid these sorts of issues, on issues of bias, on how to better kind of scrutinize your models, how to make sure they're not used in erroneous ways. So it's a little, confounding that Google's own commercial system still has this bias. Then again, this is a fairly subtle form of bias. It's not like what we've seen before, where image facial recognition systems were just way worse for black people than for white people. That was very bad. Whereas here, it's a little more subtle, you could argue, in terms of kind of picking out stereotypical adjectives instead of being sort of even. So yeah, I think, as you say, it's kind of an evolving area, and hopefully people within Google are aware of the study and are working proactively to fix their systems to remove these biases.
Yeah, I think the last part is the most important part. The part about being proactive about it. I think there's a lot of superficial. Well, the superficial answer in this case would be that the model is not biased, data is biased. So we just need to get better data. But there's been a lot of work on how do you train models to explicitly deal with these biases that might be present in your data. But also, when you're shipping a commercial product, this whole pipeline that goes from data collection to data cleaning, all this processing, to training a model and then serving the results of that model, right? Whoever's behind this, you have control over the entire pipeline, and you really have to look at bias from a much more holistic perspective.
Definitely. And I think also, speaking of a pipeline, in a sense, it starts in academia to some extent. Certainly a lot of data sets that are used for training models are still partially done by academics. And the people building these models who end up at Google probably used to be academics in many cases. So in a sense, I think this is a good argument for the broader impact statements at NeurIPS and similar kind of efforts where, if you're doing image recognition or this task of, applying adjectives to images of people in your paper, if you had a broader impact statement that said, well, maybe the adjective chosen would stereotype and cast women in a lower social role, or you could say a lower social role. If you're aware of that when you're doing research and when there aren't stakes, when you're better prepared to do it in industry. So hopefully this is maybe for people who thought that Europe's broader impact statement and didn't need to be there. Maybe this is a good example why it should be.
Right.
And on to our last story here, which, again, not very positive, but at least less bad, I think. And also maybe pretty unsurprising, just like a previous one. It's titled, AI Research Finds the Compute Divide Concentrates Power and Accelerates Inequality in the Era of Deep Learning. So this is about a paper that analyzed 171,394 papers from almost 60 computer science conferences. And then we have a paper titled The De-Democratization of AI, Deep Learning and Compute Divide in AI Research. In that paper, they showed that basically over the past decade, big companies and top-ranked universities by kind of usual metrics have published a lot more proportionally. And firms also work with prestigious universities much more. Um, I suppose unsurprising because deep learning does require compute and resources much more than AI research may be used to back in the 2010s and 2000s before deep learning was so predominant. But this is an interesting study because it actually shows quantitatively how bad it is and demonstrates that empirically this is the case and maybe something should be done about it. Yeah, I don't know. Not surprising, but kind of sad still to see this. What do you think, Jackie?
Yeah, I think as grad students studying AI, we're both acutely aware of this problem even before it was quantified in this paper. Uh, I think the problem goes beyond just the fact that you have computer. It really comes down to what extent do you want academic research to compete with industry research, right? Like it's not if you make that direct comparison, then it's obvious that it's not just compute power that's unequal. It's also access to different types of infrastructure, access to almost like an army of software engineers who can help you run experiments, conduct research, etc. But I guess to that point, one thing the paper suggests was having some sort of a national AI research cloud. And I think I'm for it, but that is just one part of the solution. At the end of the day, I think PIs, professors, when they start a lab in academia, right, they started not to necessarily compete with industry labs. Like nobody starts a lab and says, I'm going to start this lab for the sole purpose of beating out Google's lab, right? You do research because you want to discover new knowledge, you want to contribute to science and society and all of that. And the question is really what can, say in this case, what can the government do to help make sure that that's possible, especially for smaller institutions, smaller schools. And compute is just one part of that problem.
Definitely, yeah. And to that point, I think this paper also points out that this, I mean, there's multiple reasons why this is bad. Part of the reason is you don't want sort of the rich to get richer, which is sort of what's happening. The top universities are publishing more, and less prestigious universities that still have very smart people, very dedicated people, are less able to publish, seemingly. But not only that, at these less prestigious universities, you get a lot of diversity of people. So, Stanford, Berkeley, yes, you have diversity, but a lot of the people are coming from sort of well off backgrounds and maybe similar sort of life trajectories. Whereas the offers here posit that when you go beyond the top 50 universities, you get a lot more diversity, and so it would be ideal to enable these people, more diverse people, to be part of AI research and drive it. Because we know that the more diversity you have in terms of the people doing research and the kinds of minds and the kind of backgrounds you include, the better. In a way, this actually relates to what we just discussed with bias, right? If you had more diversity in AI research, you would have less of a problem with bias. So, yeah, I agree. Definitely a big problem where providing compute is just part of the trick, and you need also resources and a sort of cultural shift to maybe care a little less about prestige and more about results, and enabling as many people as possible to be part of the community.
Yeah, and I think I'm cautiously optimistic. Just going through recent conferences, there has definitely been more discussion on both this resource divide and also improving diversity in research. We've seen more and more organizations that pop up to address these issues, and also it comes down to making sure we have diverse students in grad schools and helping address that issue through the application process as well. So we've seen a lot of efforts like that, especially in the last year or so. So I am cautiously optimistic.
Yep, same. And yeah, it's good to see this paper maybe making an empirical case that the problem is there, and maybe that will spur even more work along those lines. And with that, we are going to wrap up. Apologies, listeners, for the set of bummer news stories. That's just how it was. But hopefully our US listeners can now enjoy their vacation and not think about things that are bad with AI. Thank you so much for listening to this week's episode of Scanner Today's Let's Talk AI podcast. You can find the articles we discussed here today and subscribe to our weekly newsletter with similar ones at scannertoday.com. Subscribe to us wherever you get your podcasts if you have not yet. And don't forget to leave us a rating and a review if you like the show. We would really appreciate your feedback. And be sure to tune in next week.